Okay, very good morning to all. Today we will discuss the concept of 8255 programmable peripheral interface. First of all, the name should be very clear that why it is known as an interface. Actually, whenever microprocessor want to communicate with peripheral devices, so microprocessor cannot directly communicate with peripheral devices. In the same way, if peripheral devices wants to communicate with microprocessor, so peripheral devices cannot directly communicate with microprocessor. Okay, so these two devices actually require an interface. So 8255 is basically used as an interface between microprocessor and peripheral devices, or we can say that input output devices. Okay, it is just like an operating system. Operating system is basically an interface that can be used between user and hardware. That means user cannot directly perform their operations with computer hardware. So it required, he or she required an interface. In the same way, microprocessor cannot directly communicate with peripheral devices. Okay, so that's why 8255 is basically used as an interface between microprocessor and peripheral devices. Now the next question is that why it is programmable. Actually, when microprocessor want to communicate with input output devices or input output device communicating with microprocessor, so this communication is basically programmable. Okay, that means we can program for that. So that's why this 8255 is a programmable peripheral interface device. Okay, so the name is clear why 8255 is programmable peripheral interface device. Okay, now we will start with the basic features of 8255. Actually, 8255 basically contain three ports: port A, port B, and port C. Each port have 8 lines. That means total 24 input output lines are there in 8255 interface. Out of these three ports, port A, port B, and port C is divided into two parts. That means 4 lines upper part and 4 lines lower part. Okay, and all these three ports are basically programmed either as input port or output port. Okay, the programming is basically performed or decided by mode. Okay, what is actually mode, we will discuss it later. Okay, so but before starting the conversation of mode, first of all it should be clear that these three ports, port A and port B, port C, is basically grouped into two groups. The first group name is group A and the second one is known as group B. Group A basically contain port A and upper part of port C. As I earlier told you that port C is divided into two parts. The first one is upper part and the next one is lower part. Okay, so group A basically contain port A and the upper part of port C, that is four upper line of port C. And group B is divided into group B basically contain port B and lower part of port C. It's clear to all? Okay. Now each groups, that means these two groups, is basically programmed via two different modes. The first mode is known as bit set oblique reset mode. This bit set oblique reset mode is basically used to set or reset the bits of port C. Okay, and the next one is your input output mode. As I told you in third line that each port can be programmed either as an input port or output port. So let's suppose if the port is working as an input port, then input mode is basically used. If port is basically working as an output port, that means output mode is basically used. Okay, so how can we decide that the port is input or output? With the help of input output mode. Okay, input output mode is again divided into three parts, that is mode 0, mode 1 and mode 2. Mode 0 is simple input output, mode 1 is stopped input output, and mode 2 is stopped bidirectional input output. What do you mean by stopped? That means stop pulse is basically required. Okay, and mode 0 is basically your simple input output. So that is the basic features of 8255 interface. Now we are just moving towards the block diagram of 8255 programmable peripheral interface device. So as I earlier told you that when we are using 8085 or 8086 microprocessor, so for processing of that microprocessor, some power or supply is required. Okay, so in the same way, when we are using 8255 programmable peripheral device, then plus 5 volt power supply is required. Okay, and if we are providing power supply, then ground connection is also required for that. That is the basic requirement for 8255 programmable peripheral devices. So this 8255 is basically have separate components. The first component is your data bus buffer. The next one is read write control logics. The next one is group A and group B control. The next one is port, that is port A, port B and port C. Okay, so now we will start with one by one. The first one is the data bus buffer. What is data bus buffer? Data bus buffer basically contains the data information, okay, and that data information may be accessed by the microprocessor, or it may be accessed by the 8255 programmable device, through which the input output device can access that particular information. Okay, so data bus buffer is basically worked as an interface between system bus, and this is your internal bus. Why this is known as system bus? Actually, as I earlier told you that when microprocessor wants to communicate with outside environment, then the bus that the microprocessor is actually used is known as system bus. Okay, so this bus is basically used by the for the communication to the outside environment, that means peripheral devices. That's why this bus is basically called as system bus. Okay, and system, we know that system bus is the combination of data bus, control bus and address bus. So data bus information will be here and the address and control information will be here. Okay, so let's suppose if the microprocessor wants to communicate with peripheral devices. Okay, so microprocessor sends the 8-bit information to this data bus, to this system data bus, and then that 8-bit information is reached towards data bus buffer, and then with the help of internal data bus of 8255, this data bus buffer information is moved towards different port. Okay, to the ports that is basically required to communicate with peripheral devices. So in this way, the microprocessor can communicate with peripheral devices. Data bus buffer not only store the data information, it also store the control word information as well as status signal information. The control word information is basically received by read write control logics, that is actually stored in this data bus buffer. Okay, so this is basically your control word. This is also used to store the control word information. Now the next question is that what is this control word? Control word is basically the control word basically provided by the microprocessor, and this control word is basically used to control the internal components of 8255 programmable devices. What do you mean by controlling? Controlling means which mode is basically used by the different port. That means input mode is used or output mode is used, or that means port A, port B, port C will be your input port or output port. Now the next one is we are using input output mode or bit set or reset mode. Okay, so this control word basically provide all this information. It's clear to all. So this control word information is basically provided by microprocessor, and these control word information can be stored in data bus buffer. Okay, so that's why we generally use data bus buffer. Now the next one is read write control logic. Read write controller, this is basically your control signals that is provided by the control as well as address bus of the microprocessor. So with the help of control and address bus, the control signals is provided, and finally this read write control logic provides the control information. Read write control logics basically have different signals. The first one is RD complement, next one is WR complement, A1, A0, reset, chip complement, chip select complement. Okay, so read write and chip select complement is your active low signals. Okay, so when the input is 0, then this particular line is enabled. So when RD complement is equal to 0, that means read signal is enabled. When WR complement is enabled, that means write signal is enabled. A0 and A1 is basically provide the port address. That means when A0 and A1 is equal to 00, then it will provide the address of port A. When it is 01, then it will provide the address of port B. When it is 10, then it will provide the address of port C. When it is 11, that means the control word information is transferred to the data bus. Okay, that means the control word information is stored in this data bus. That is the basic meaning of A0 and A1. Read complement, write complement. As a read complement means read. What do you mean by read? Let's suppose microprocessor want to receive some information from peripheral devices. So that is your read operations. When microprocessor want to send some information to peripheral devices, that is your write operations. Okay. Reset is basically used to reset the content of control word. When the control word content is reset, that means all these port A, port B and port C will be working in input mode by default. So that is basically the meaning of reset. Next one is chip select complement. So that is your active low signal. When the value of chip select complement is equal to 0, at that particular time the microprocessor can be able to communicate with 8255 programmable peripheral devices. Okay, so that's why we generally use chip select complement. Okay, now the next component is your group A and group B controls. So when the control signals are basically provided, then these control signals are sent to the group A and group B. As we know that the group A and group B is basically the combination of port. As I earlier told you that group A is the combination of port A and upper part of port C. Group B is the combination of port B and lower part of port C. Okay, so this group A and group B controls basically controls their group port. That means this group A control signals can provide the control information to the group A port A and group A port C. Okay, group B provide the control signals to the lower part of port C and to the port B. Okay, so that's why these two group controls basically used. Okay, these two group controls control means we just control that which mode is basically used by the particular port, that is input mode or output mode, and bit set or reset mode. Okay, now the next one is this port A, port B and port C. Actually I earlier told you that port A, port B and port C basically contain 8 lines. Okay, so here for port A we have it basically contain 8 lines for input output latch and 8 lines for output latch. Okay, group B, port B basically contain 8 lines for input output buffer oblique latch, and port A basically one 8-bit data output latch buffer and one 8-bit data input latch. Port B one 8-bit data output latch buffer and one 8-bit data input buffer. Okay, it's clear to all. So output buffer and input buffer, what does it means? Output buffer means that port is basically working as an output mode. Input buffer or latch means that port will be working as an input mode. Okay, so that is the meaning of port A, port B and port C. As I earlier told you that port C is again divided into two parts, the lower part of port C and the upper part of port C. Okay, now the remaining things of 8255 programmable peripheral devices will be covered in next lecture. Thank you so much.